Okay, extremely sorry for the delay. So we started discussion on that laser, right? So we have discussed about that spontaneous emission, stimulated absorption as well as stimulated emission, and we have at the end we conclude that stimulated emission that is necessary to produce laser light, and for that we must need this condition that population of E2 should be greater than population of ground state. Okay, and this condition is known as population inversion. Okay. Now we start discussion on that component of laser. Components of laser. Okay. So to discuss this, we must need to draw the diagram. So you have a mirror M1 with reflection R on, that is 100%. And this side you have a mirror M2 with reflection R2. Okay, so this would be M2 with reflection R2, and that will be around 99%. And inside this mirror, you have a inside this medium or mirror, you have a active medium. And this side, you have a pumping source. Okay. And in active medium, you have a level. You have a level E1 and E2. Okay. And at E2, that number of atoms, N2, and E1, number of atoms per unit volume, that is N1. So N1 and N2 basically defined as number of atom per unit volume. Okay, this is nothing but atomic density, you can say. So if you see that components of laser, it has basically three components. First of all, active medium. So we can mention that active medium is the collection of atoms or ions or molecules. Active medium is the collection of atoms or ions or molecules in which atomic transition takes place to produce laser light. It is the collection of atoms or ions or molecules in which atomic transition takes place to produce laser light. इसका मतलब ये है एक्टिव मीडियम वो मीडियम है जहां पे आपका वो लेवल्स होता है E1 and E2, जहां से आपका लेजर लाइट प्रोड्यूस होता है. Further, you can mention that active medium can be solid or liquid or gas. It can be solid or it can be liquid or it can be gas. Okay. For example, example A, you have a ruby laser. You have a ruby laser. In ruby laser, active medium is nothing but chromium 3+ ions. So in ruby laser, chromium 3+ ions is basically act as a active medium. Then you have a second kind of laser that is known as helium neon laser. In helium neon laser, neon atoms basically act as a active medium. Okay, so it can be solid or it can be liquid or it can be gas. Okay, so active medium वो medium है जहां पे आपका इॉन एंड E2 लेवल्स होता है और जिसके कारण आपका बेसिकली लेजर लाइट प्रोड्यूस होता है. Okay, then you have second component that is known as pumping source. You have a second component of laser that is known as pumping source.
Say in helium neon laser, what is active medium?
Neon atoms.
Okay, sir.
Okay, so second components of laser that is known as pumping source. So you have a systems of two levels, E2 with atoms N2, and you have a ion with atoms N1. Okay, in general, atoms like to stay in the ground state. So most of the atoms will be at ground state, right? But to produce laser light, we must need N2 greater than N1. So what we have to do, we have to pump that atoms. We have to pump that atoms from ground state to excited state. To produce laser, we must need to achieve this condition, but initially atoms like to stay in the ground state to minimize that energy. So we have to pump this atom by using pumping source. And if you see the type of pumping source, so you have a first type is known as optical pumping. So for optical pumping, basically, this is your levels E1 and E2. In optical pumping, basically, photons or light are used. Photons or light are basically used to pump the atom from E1 to E2. Okay, photons or light basically used to pump that atom from E1 to E2 or from ground state to excited state.
Hello, sir.
Yes.
Can you repeat once more this line, sir?
Yeah, what I'm saying, that pumping, we must need to pump that atom from E1 to E2. So for that, we need pumping source. So there are various kind of pumping source, and one of them is optical pumping. In optical pumping, what we have to use, we basically use that light or photons that we have to shine inside that system, and atoms at the ground state, it will absorb these photons, incoming photons, and it will make transition. So in that way, we can achieve that population inversion. Are you getting what I'm saying?
Yes, sir.
Okay. Then second type of pumping source, that is B. This is known as electrical pumping. Okay, so for optical pumping, example of optical pumping, basically, you have we mentioned in optical pumping. Example of optical pumping, for example, you have a ruby laser. You have a ruby laser in which we used flash lamp. Use flash lamp to pump that atom from E1 to E2. So example of optical pumping source. Optical pumping source basically we use in ruby laser. And ruby laser, we have an optical pumping source that is known as flash lamp. So flash lamp will produce light, and these atoms will absorb this light and it will jump to E2. Then you have an electrical pumping. In electrical pumping, basically, again you have a two levels, E1 and E2. In electrical pumping, you have a basically high energetic electron that will basically incident on that system, and atoms at ground state will absorb this. The atoms at the ground state will absorb the energy from high energetic electron. As a result, it will make transition from E1 to E2. Okay. So basically, a high energetic electron will contribute or will donate the energy to atoms at the ground state. As a result, these atoms will make transition from E1 to E2 to achieve this population inversion. Okay. Example of electrical pumping. You have a helium neon laser. You have a helium neon laser in which we basically use a high energetic electron. Okay. Is this clear what I'm saying?
Yes, sir.
Yes, sir.
Then third component of laser, that is known as optical resonator. Third component is known as, sorry, optical resonator. Optical resonator is nothing but a pair of mirrors, M1 and M2, having specific separation. Having specific separation D. Okay. So you can mention that optical resonator is nothing but a pair of mirrors having specific separation, that is D. Is nothing but a pair of mirrors having specific separation D. Okay. Now, to understand that how that laser light is producing, let us understand that mechanism. So what is happening? You have a pumping source. So suppose you have a flash lamp. You have a flash lamp. This lamp is actually giving or donating photons, and atoms at ion will absorb these photons. And what will happen? First of all, what will happen? These photons will be absorbed by atoms at ion, and it will make transition to E2. And whenever this condition achieved, N2 greater than N1, then what will happen? First process will happen, that is known as spontaneous emission. So atoms will make transition from E2 to E1 when after achieving this population inversion. So as a result, first transition happening from upper level to lower level by the process of spontaneous emission. As a result, there will be emission of photon. And let us assume this photon is going like this in this direction. Since this mirror is highly reflecting, so what will happen? It will incident on this mirror, and after that it will be reflected back, and it will go in the forward direction. Now when it is going in the forward direction, you have large number of atoms at E2, and these atoms, due to the interaction of this EM wave with these atoms at E2, there will be stimulated emission. As a result, what will happen? You will have two photons at the output. Again, these two photons will again backscattered by this mirror because of high reflectivity. As a result, you will get, when these two photons interacting with atoms at E2, as a result, there will be two more stimulated emission. So as a result, you will get 4 photons here. Again, it will, when it will interact with system, at the end you will get 8 photons. So within a fraction of time, you will have large number of photons inside that cavity. Within a
Sir,
fraction, yes.
sir, can you one more time explain this process?
Actually, in that stage, when after pumping, so what happened? That is not.
Yes, I'm telling. So first of all, you are using this pumping source to achieve population inversion. So atom will be pumped from E1 to E2. Okay. Then first transition from E2 to E1, that will be by spontaneous emission. That will be by spontaneous emission. As a result, you will have a photon, emission of photon. And let us assume this photon is traveling in this direction. Okay. Now, due to high reflectivity, these photons will be reflected and it will go forward direction. And this photon will interact with atoms at E2, at level E2, and it will make stimulated emission. As a result, you will have two photons moving in the forward direction. Again, due to high reflectivity of this mirror, it will be reflected back. You have a two photons, okay, and it will further produce two stimulated emission. हर एक photon के लिए एक stimulated emission होगा. As a result, you will have four photons at the output, and it will go in the backward direction. And again, due to high reflectivity, it will go to forward direction, the reflected photons. Now you have four photons, it will make further four stimulated emission. As a result, you will have 8 photons at the output, and it will go forward direction. Again, due to high reflectivity, these 8 photons will come back, and it will further create 8 stimulated emission. As a result, you will have 16 photons here. So this process is happening happening within a very short time. So what I'm saying, within a fraction of time, you will have large number of photons inside this cavity.
Sir,
Hmm.
sir, after reflection,
Hmm.
spontaneous absorption can also take place.
Spontaneous absorption is not possible. Stimulated
Why?
absorption is happening. But why I'm not talking about this stimulated absorption? That will be possible. But you see, the process that will be dominated, that will be stimulated emission. Why? Because we already have achieved,
N2 is greater than N1.
we already have achieved this condition. So the dominated process will be stimulated emission. Okay.
Oh, okay, sir.
That's why you are dealing with this only stimulated emission. Definitely,
sir.
there will be stimulated absorption also, but dominated process will be what? That will be stimulated emission.
Sir,
Yes.
pumping source basically pumps the atoms from E1 to E2. Is it so? So can we do like this? We insert directly atoms into E2. Is it possible? Because ultimate aim is that only.
Sorry, I am not getting what you are saying.
Sir, what does pumping source do? It transfers atom from E1 to E2, na? So is it possible that directly atoms are added in a E2 stage so that why?
So how will transfer that atom from E1 to E2 without any pumping? It's not possible actually. Directly you cannot transfer that atom from E1 to E2. I don't think so. We must need pumping source to pump that atom. Directly, how will you transfer that atom? We are dealing only with what? We are dealing with quantum particle, right? Electrons. So directly, how is it possible to transfer that quantum particle from lower state to higher state? Is it true or is it fine?
Sir,
Yes.
pumping source means we give some energy to atoms in ground state, na sir?
Yes.
Okay.
Just now I discussed a pumping source, like you have a flash lamp for ruby laser. Flash lamp is nothing but you have a large number of photons, right? So these photons actually pumping that atom from E1 to E2, and you have to maintain this photon. You have to pump that photons continuously. Sorry, you have to pump that atom continuously. Frequently आपको pump करना पड़ेगा. क्यों? क्योंकि आप जैसे pump कर रहे हो, there is a possibility that atom will jump from E2 to E1 by spontaneous process, है ना? So you have to give that you have to pump that atom frequently, continuously आपको pump करना पड़ेगा to maintain that population inversion. Okay, so pumping you can be that can be achieved by using flash lamp, or it can be achieved by using high energetic electron. Is this clear? Shall I proceed?
sir.
Is this clear? Or you have a doubt? Please ask me. Or I have to repeat. Please tell me.
Clear, sir, clear.
Everyone clear? Puneet?
Yes, sir. समझ आ गया sir.
हाँ, सबको समझ में आया? Can you please confirm me so that I can proceed? Okay.
Yes, sir.
Yes, sir.
So to achieve population inversion, we must need to pump that atom from E1 to E2. And for that, we need pumping source. And first mechanism to produce that photons by spontaneous, that will be spontaneous emission, and that photon will be going backward, forward, and it will enhance that stimulated process. As a result, within a fraction of time, you will have large number of photons inside this cavity. Okay, so you'll have that optical resonator is basically creating large intensity inside this cavity, है ना? जैसे आप मिरर क्यों यूज कर रहे हो, हर एक कंपोनेंट का एक रोल है. मिरर क्यों यूज कर रहे हो, क्योंकि ताकि वो फोटोन क्या करे, दैट विल बी ऑसिलेट करे विद इन दैट कैविटी, है ना? अगर फोटोन बाहर चला गया तो फिर आपका फोटोन क्रिएट ही नहीं होगा ना इनसाइड. So that optical resonator, actually the role of optical resonator to bound that photons, whatever photons are creating, to bound that photons. So within a fraction of time, you will have large number of photons inside this cavity. Okay. Now we'll understand that Einstein. Yeah. Yes.
सर जो दूसरा मिरर है उसकी रिफ्लेक्टिविटी हम लोग 99% को रखते हैं.
हाँ, उसी से आपका जो आपको आउटपुट में जो लेजर मिलता है पुनीत, दैट इज बिकॉज ऑफ दिस. जो लाइट पास हो रहा है उस मिरर से, जो लाइट पास हो रहा है ना, द फैक्ट ऑन परसेंटेज जो लाइट पास हो रहा है, दैट इटसेल्फ ए ह्यूज नंबर, because within a cavity you have large number of photons, infinite number of photons. So 1% of this itself a big number. तो वहां से आपका बेसिकली लेजर लाइट प्रोड्यूस हो रहा है, पास हो रहा है, जो आपको आउटपुट में मिल रहा है. Do you get what I'm saying?
यस सर.
सर ये पॉइंट जरा फिर से मतलब.
हाँ, जैसे आपका ये आपका कैविटी है, इसमें आप क्या कर रहे हो, लार्ज नंबर ऑफ फोटोन्स क्रिएट कर रहे हो ना. इसका 1% क्यों रखे हो, क्योंकि आपको आउटपुट, आपको क्या आउटपुट, ये तो आप यहाँ पे लाइट प्रोड्यूस कर रहे हो, बट आउटपुट कहाँ से मिलेगा, जो इसका 1% रिफ्लेक्ट, मतलब इसका 99% रिफ्लेक्टिविटी है ना, तो 1% ऑफ दिस फोटोन विल बी पास, एंड दैट इज एक्चुअली योर लेजर लाइट.
ओके सर, क्लियर, थैंक यू सर.
Okay, now we'll understand that why that Einstein coefficient is so significant to produce laser light. So we already used to derive that coefficient, but it has great significance actually for the selection of material. What type of material is usable to produce laser light? Okay, so we'll understand that actually from Einstein coefficient. So now we'll discuss that Einstein coefficient. Okay, so to discuss this, we must need to draw again same level. You have two levels, E2, E1. Okay, and E2 is greater than E1. Yes.
So you said that the significance of Einstein coefficient is to
Einstein coefficient is very much significant, that it will tell you what type of material is suitable to produce laser light. So basically Einstein coefficient will help you to select the type of material for production of laser light. That we'll see at the end. At the end we'll see that. Okay. So you have two levels, E2 and E1. Number of atoms at E2, number of atoms per unit volume, that is N2, here N1, and tau sp is the spontaneous lifetime of this level E2, and separation between these two level, that is delta E. Okay, delta E. Okay, now you are signing the photon. You are signing the photon. The energy of this photon is h cross omega. Okay, or you can write h nu, that is matching with the energy gap delta E. Okay, and energy density of this photon, that is U of omega. Okay, to discuss about this Einstein coefficient, we must need to describe this parameter. So what is EON actually? EON is ground state energy level. And Anon actually what? Number of atoms or ions per unit volume at where? At level EON. Then you have a E2. E2 is what? Excited state energy level. Okay, and N2 is what? Number of atoms or ions per unit volume at level E2. Okay. Then you have U of omega. U of omega. What is U of omega? Energy density. Energy density of incoming photon. Incoming photons. Okay. Okay. And delta E, you know, delta E is what basically separation between two levels. Separation between E2 and E1. Separation between E2 and E1. Okay. Is this clear? इतना लिख लिया आप लोगों ने?
Yes, sir.
Shall I erase this part?
Yes, sir.
Now, can you please tell me that rate of spontaneous emission will be how much? Rate of spontaneous emission. Emission. इसी को बोलते हैं रेट इक्वेशन. Rate equation for spontaneous emission. So I can write this rate dN2 by dt. Spontaneous Sp dot emission EMS. That will be proportional to what?
N2.
Exactly. It should be N2. Okay. It means dN2 by dt. I can remove this proportionality constant and I can write A21 N2. And what is A21?
Einstein coefficient.
Einstein coefficient.
So minus sign by
I'll tell.
just
Einstein coefficient of spontaneous emission. Okay. Now, why there is a minus sign? Because minus sign is telling with progressive time, the population of N2 is decreasing with this process. जैसे dN2 by dt को लिखते हो आप. dN2 is dN by dt is nothing but population of final level, final time, I mean final population minus initial population by TF minus TI. Now TF minus
Sir, वो
TI.
board में नहीं आ रहा.
नहीं आ रहा है. Okay. But I'm
Yes, sir.
saying this minus sign is telling with progressive time, the population of E2 is decreasing. So dNT by dt, how will dN by dt? What is meaning of this? It means final population minus initial population divided by final time minus initial time, right?
Yes, sir.
So TF minus TI, this actually what? This is actually positive number because you are with progressive time you are looking. Okay, TF minus TI, that will be positive number, but NF minus NI, that will be negative because this process actually decreasing the population of E2. So population of E2 at final minus initial, that will be negative. So the significance of this minus actually, what does it telling? With progressive time, the population of E2 is decreasing by spontaneous process. Is this clear what I'm saying?
Final level here is E2 level, na, we are considering.
We are only discussing with spontaneous emission. So rate of change of population of E2 with time. So it should be negative because the spontaneous emission actually decreasing the population of E2. So we have to use this minus sign. Same thing we learn in radioactivity as well, right? जब आपका number of atoms वहां पे कम होता है, वहां पे भी हम minus sign use करते हैं. क्यों? Because with progressive time, your number of population actually decreasing there. Did you get what I'm saying? Is this clear or I have to repeat again?
Yes, sir.
Kanchan,
Sir,
is
it
this
is clear.
Kanchan, is it clear?
Yes, sir.
No, if you have doubt, I can repeat further. Please
No,
tell me.
sir, I'm only getting not getting this, that why we are the transition is from E2 to E1 na. So final state should be of E1 na.
No.
Minus state I
No.
understand.
Final state not E1. You are this we are only dealing with, you see, we are not using here N on here. So we are looking that rate of change of population of level what level? कौन सा level का rate of change of population? E2 का.
E2 level.
We are only focusing on E2 level. So rate of change of population of E2 level by spontaneous emission, what will happen? Rate of change of population of E2 level by spontaneous emission should be decreased with time.
Yes, sir.
So you are only dealing with spontaneous process. So this should be negative. Now we'll discuss more about this. Now, can I write from here that dN2 by N2, dN2 by N2, 1 minute. I have to remove this. ये सारे माइनस साइन हम वहां पे भी यूज करते हैं. If you remember, when we study that radioactivity, same sign we are using there also. Minus sign means जब आपका population decrease होता है time के साथ, तब हम minus sign को use करते हैं. Do you remember this equation? dN by dt equals to minus lambda n. Do you remember? There also you use same sign.
Yes, sir.
Okay. Now from this equation, can I write like this? That dN2 by N2. That should be equal to how much, Punit? A2 on dt, right?
Yes, sir.
Okay. Now if I integrate this, now at time t equals to 0, population of E2, that is N2 0. At time t equals to t, population of E2, let us assume that is N2 t. Now if I integrate and substitute that limit, how much I'll get? dN2 by N2, how much it will be? ln N2, right? dx by x क्या होता है? ln x होता है, right? Then you have a limit that is N2 0 and N2 t. And this side you have how much? Minus A2 on t, right? Is this clear what I'm saying?
Yes, sir.
So from here I can further write that ln N2 t divided by N2 0. That should be equals to minus A2 on t. It means N2 t, that should be equal to how much? N2 0 exponential minus A2 on t. Okay. So it means there is an exponential decay of population E2 by spontaneous process. There is exponential decay of population of level E2 by spontaneous process. So if I draw that diagram, N2 as a function of time, then how it will look like? There will be exponential decay. And remember that exponential decay can never be zero. It can only be zero when time t equals to infinity. It can only be zero when time t equals to infinity, and that is not physically significant. Then what is tau sp? Tau sp क्या है actually? So tau sp actually the time टाउ एस पी जो हम लोगों ने डिफाइन किया था, टाउ एस पी स्पॉन्टेनियस लाइफ टाइम ऑफ E2. Tau sp is the lifetime, or tau sp is the time. Tau sp is the time at which the population of E2 reduces to 1 by E times of its initial value. तो यहां से हम क्या लिख सकते हैं? That tau sp is the time at which population of E2 reduces to 1 by E times of its initial value. मतलब ये एक टाइम है, टी के जगह पे हम क्या यूज करेंगे? टाउ एस पी. एंड इस टाइम में क्या हो जाएगा आपका? when t equals to tau sp, then what will happen? That population of this level will be reduces to one of its initial value. Initial value क्या है? n20 divided by e, or I can write e की power -1. So at t equals to tau sp, the population of E2 will be n20 exponential -1. So it means this will be cancelled, and I'll get tau sp should be equals to, if I compare that power, exponent power, then what I can write, that tau sp should be equals to how much, Puneet? कितना हो जाएगा भाई, बोलो?
1/A2.
Exactly, 1 by A21. So this formula is important for your exam. Okay, so if you know, yes.
Sir, please explain this last step. What you did? You have.
So what is spontaneous lifetime? Spontaneous lifetime मतलब ये time है t equals to, मतलब time at which, at time t equals to tau sp, that n2 t will be becomes n20 by e. Okay, and you have this is your original equation. Now if I substitute that in place of t equals to tau sp, then what I'll get? This will be the expression, and this expression I can write n20 divided by e, and this e I can write exponential -1. So this n20 will be cancelled. Now if I compare that power of exponent, then this A21 tau sp should be equals to 1. It means tau sp will be 1 by A21. So it means at t equals to tau sp, suppose this is your t equals to tau sp, at this time that population of E2 will be how much? n20 by e. So this formula is really important for your exam. So if you know that Einstein coefficient, I can calculate that spontaneous lifetime. Is this clear what I'm saying? क्या इतना clear है?
Yes, sir.
Yes, sir.
And remember that spontaneous emission process actually downward process. Spontaneous process मतलब क्या है? Spontaneous process is nothing but downward transition. क्यों? क्योंकि spontaneous process में क्या हो रहा है? Upward से atom downward में jump कर रहा है. इसका मतलब क्या है? Spontaneous is nothing but downward transition, है ना?
Yes, sir.
Then you have a second type of process. This is known as stimulated emission. So I can write that rate of stimulated emission. So I can write like this: dN2 by dt stimulated st dot EMS, and that will be proportional to what? That will be proportional to what? Number of population at E2 as well as energy density of incoming photon. So further I can write, if I remove this proportionality constant, I can write dN2 by dt, that should be equals to minus B21. Then you have N2 U of omega. Again, I am using this minus sign because stimulated emission actually decreasing the population of E2. So again, minus sign because of what? With progressive time, the population of E2 is decreasing by stimulated emission. And what is B21 here? B21 is nothing but Einstein Einstein coefficient of stimulated emission. So again, that stimulated emission is nothing but downward transition, right? Stimulated emission is nothing but downward transition because atom is making transition from E2 to E1. Then you have a third type of process. Shall I erase this part? Can I erase? Please respond me.
Yes, sir. Am I audible, sir?
Yes.
Yes, sir. You can erase, sir.
Now, next process, that is rate of stimulated absorption. Rate of stimulated absorption. So that will be what? D यहाँ पे क्या हो जाएगा? Stimulated absorption के लिए dN by dt stimulated absorption. So what I can write here? St dot abs. And that will be proportional to what?
N1.
Exactly. It should be N on U of omega. Okay. So if you remove this proportionality constant, what I can write here, that minus B on 2 N on U of omega. Again, you have a minus sign here because with progressive time, that stimulated absorption is decreasing that population of E1. With progressive time, this process is actually decreasing that population of level E1 or ground state, you can say. And beyond 2, you can mention also. Beyond 2 क्या है? Einstein coefficient of stimulated absorption. Is this clear? Is this clear to all?
Yes, sir.
Kanchan, is this clear? Puneet and all others?
It's clear.
Yes, sir.
Okay, now at thermal equilibrium, what will happen at thermal equilibrium?
Rate of absorption is equal to emission.
So at thermal equilibrium, rate of upward transition should be equal to rate of downward transition. Equilibrium matlab there is no change in population of each level. So at thermal equilibrium, rate of upward transition should be same as rate of downward transition. So upward transition किसके लिए हो रहा है? That is because of stimulated absorption. Downward transition किसके लिए हो रहा है? That is because of spontaneous emission as well as stimulated emission. So I can write at thermal equilibrium, that rate of upward transition, that will be how much? That will be nothing but V on 2 N on U of omega. Okay, this is the rate of upward transition, and that should be same as downward transition. So downward मतलब एक आपका spontaneous emission का कारण कितना होता है? A2 on N2, and then you have a stimulated emission, and rate of stimulated emission is how much? That is nothing but B2 on, then you have N2 as well as U omega. So rate of upward matlab rate of stimulated absorption, that will be balanced with this. So you have a rate of spontaneous emission, rate of stimulated emission. I can cancel this minus sign, and if I bring this term, second term here on the left hand side, then how much I'll get? You can see U omega I'll get common. I'll get U omega common, right? And you have this factor B on 2 N on minus B2 on N2, and that should be same as A2 on N2. It
Sir,
means, yes.
sir, in spontaneous absorption and stimulated emission, we have multiplied by U of omega. Sir, what is the reason for it?
Because this spontaneous stimulated absorption is happening because of incoming photon, है ना? जितना number of photons ज्यादा होंगे आपका system में, उतना ही spontaneous stimulated emission and stimulated absorption ज्यादा होंगे. Because it is not happening spontaneously. Yes, stimulated emission, this term itself is saying it is not happening spontaneously. This
It
is
is
happening because
stimulated.
of incoming photon. तो जितना incoming photons आपका ज्यादा होंगे, photon density जितना ज्यादा होंगे, obviously stimulated emission and stimulated absorption ज्यादा होंगे. Okay, but you are I think you are doing one mistake. That is, you are every time you are saying that spontaneous absorption like that. You are saying like this. It's not like this. Stimulated emission and stimulated absorption.
Oh, okay, sir. Okay, sir.
So from here, what I can write, that energy density of incoming photon, that should be equal to how much? A21, then you have N2 divided by B1 to N on and B2 on N2, right? So then I can take that second term common as well. If I take, तो यहाँ पे कितना हो जाएगा आपका B on to N on minus B2 on N2, right? You'll get like this. Now if I take, I can write like this, A2 on N2, and in denominator I can take this term common. So if I take this term common, it will be B2 on N2, then you have B on 2 N on divided by B2 on N2 minus 1, right? And this N2 will be cancelled. This N2 will be cancelled, and I'll get that energy, the density of photon, incoming photon, that will be how much? कितना हो जाएगा? It will be A2 on by B2 on, and you have a what? N on by N2, B on 2 by B2 on minus 1. Is this clear what I'm saying?
Yes, sir.
Yes, sir.
Okay. Now we have a further, we have to main part is actually remaining, but I think time is over. You have one more class. आपका class का time हो गया? देखो, please check करो.
Yes, sir.
So should I stop here or I can proceed? Tell me.
We can stop here today.
Okay. So main part actually remaining. This is all about mathematics, but we didn't conclude what is the significance of this coefficient. So tomorrow I'll conclude and I'll tell what type of material is suitable actually for laser. Okay, so you should stop here. Okay, we have a question.
No, sir, clear.
Okay, we should stop.
Yes, sir. Thank you, sir.
Thank you, sir.